So we're asked to find the standard deviation of this discrete random variable. And so it's discrete. We call it discrete because we're talking about just a countable amount of outcomes. X could be 0, X could be 1, or X could be 8. So that's discrete. Something's continuous if you have like a function like this, like 1 over X is the probability or something like that. That's a continuous function because X could be 0.1, X could be 1.1, X could be 1.11. There's an infinite amount of options there. So this is discrete, and to find the standard deviation, we need to use this formula. Okay, so this is the formula for the variance. Okay, to get the standard deviation, you just need to take a square root. And what the formula is saying is take each value for x, so 0, 1, and 8. You've got to do this 3 times because it's 3 values for x. You subtract it by the mean, which is just the expected value, which I'll help you calculate in just a second. You square that difference, and then multiply it by the probability. If you didn't do the squaring part, adding all these up, it should make 0 without the probability involved. I have to think about that. But it should make 0 because the mean is the perfect center point. But if you square it, then all those negative numbers become positive. Okay, so first thing we need is the mean. Let's do that. The expected value of the x is the mean of the distribution. And the expected value is found by taking each value for x, multiplying it by the probability. So 1 times 1/3, then we got 8 times 1/2. So 0 times 1/6 is 0. 1 times 1/3 is 1/3. 8 times 1/2 is 4. And so as a decimal, because I think that's what our program uses, it's 4.3 repeating. So that's our mean. So to calculate the standard deviation, I'm going to take each value for x, subtract it by that mean, square that result, and then multiply it by the probability of getting that result. And it's plus the next one. 1 subtracted by 4.3 repeating squared times 1/3. And then it's 8 minus 4.3 repeating squared times 1/2. Okay, so you make all those calculations, then you'll have the mean of the distribution. So I'll do them real quick. So the first one, I got this for the term. Oh, it's going to have to go down here. The next one, that's carrying out a few decimals. I think it says we round this one to the nearest hundredths, but it's good to carry out some decimals in the calculations in between. So the next one, and then the last one, square that result, and then that was times 1/2, so divided by 2. Okay, we still have to take a square root. Sorry about the dog. Hubs. Nope. So add those together. And then we take the square root. So the standard deviation is 3.68 when we round to the nearest hundredths.